There are moments in astronomy when a discovery simply adds another piece to the puzzle. Then there are moments when new observations force scientists to reconsider how that puzzle was assembled in the first place. The James Webb Space Telescope, or Webb, has brought us closer to one of those moments. Webb was designed to observe extremely distant objects whose ancient light has traveled across billions of years. Because light takes time to travel, looking deeper into space also means looking further into the past. This allows astronomers to study periods when the universe was still incredibly young. According to the standard cosmological picture, the universe began approximately 13.8 billion years ago. After the Big Bang, it expanded and cooled. Matter gradually gathered under gravity, eventually producing the first stars and galaxies. The expected process was not instantaneous. Small structures were supposed to form first. Gas would collapse, stars would ignite, galaxies would grow, and heavier elements would gradually accumulate. Over hundreds of millions and billions of years, increasingly complex systems would emerge. But Webb has revealed early galaxies that appear surprisingly bright, compact, massive, or active. One notable example is JADE's GSZ 14-0, a galaxy observed from a period when the universe was only a few hundred million years old. Its existence is fascinating because it demonstrates that substantial galactic activity was already underway extremely early in cosmic history. The important question is not whether this galaxy somehow existed before the Big Bang. Webb has not shown that. The real question is simpler and more scientifically useful. How did galaxies become so active so quickly? For a galaxy to shine, enormous quantities of gas must collapse and form stars. Those stars produce radiation and gradually alter their surroundings. Some galaxies may also contain rapidly growing black holes that contribute additional energy. Webb has also detected numerous compact objects informally called little red dots. Their unusual combination of brightness, compactness, and red color has attracted considerable attention. Scientists are investigating whether these objects are young galaxies, systems dominated by active black holes, short-lived stages of galaxy evolution, or combinations of several processes. These discoveries do not automatically mean that the laws of physics have failed. Instead, they suggest that the early universe may have operated more efficiently than some earlier models assumed. Perhaps gas collapsed faster. Perhaps stars formed in unusually dense environments. Perhaps early galaxies experienced powerful bursts of star formation. Perhaps black holes grew rapidly and influenced their surrounding galaxies. Or perhaps several of these processes happened together. This distinction is extremely important. Webb has not disproved the Big Bang. Evidence supporting the Big Bang remains extensive, including the expansion of the universe, the cosmic microwave background, and the observed abundance of light elements. What Webb is doing is testing what happened after the universe began expanding. And that may be where the real scientific revolution lies. For decades, astronomers developed increasingly detailed models describing how galaxies should assemble. Webb now provides observations from an era that was previously difficult to examine directly. If early galaxies repeatedly appear more developed than expected, scientists must improve those models. That is not a failure of science. It is science working exactly as intended. The most fascinating part of Webb's discoveries may be that the mystery keeps growing as astronomers collect more evidence. The early universe may not have been a quiet environment slowly building complexity. Instead, it could have been an extraordinarily active period in which stars, galaxies, and black holes developed through processes that were faster and more intense than previously assumed. Some early galaxies appeared to contain enormous populations of stars packed into remarkably small regions. Others show signs that black holes may already have been feeding at impressive rates. This has created a major scientific question. What physical conditions allowed such rapid development? One possibility is that the earliest galaxies converted gas into stars extremely efficiently. Another is that dense environments encouraged unusually rapid star formation. There is also the possibility that massive early stars played a larger role than they do in galaxies today. Black holes could be another important piece. If massive black holes formed very early, they could have grown quickly by consuming surrounding material. Their energy could contribute significantly to the brightness of distant galaxies, making some objects appear more massive or developed than they actually are when viewed through simpler assumptions. This is why spectroscopy is so important. A photograph tells astronomers that a distant source exists. Spectroscopic observations provide additional information about its light, including its redshift and chemical signatures. These measurements help scientists determine how far away an object is, how old its observed light is, and what physical processes may be occurring inside it. The mysterious, little red dots are particularly interesting because their properties do not fit neatly into one simple category. Some may be connected to rapidly growing black holes. Others could represent unusual stages of galaxy development. But scientists must remain cautious. A strange observation does not automatically require a completely new theory of the universe. Astronomers have encountered unexpected results before. Sometimes the explanation comes from an overlooked physical process. Sometimes improved measurements change the interpretation. Sometimes an apparent contradiction disappears when scientists understand an object more completely. That is why Webb's discoveries should be viewed as questions rather than final answers. The telescope has not demonstrated that galaxies existed before the Big Bang. It has not proven that the universe is eternal. It has not shown that relativity is wrong. And it has not established that the universe itself is impossible. Instead, Webb has revealed that the earliest observable universe could produce surprisingly bright and complex systems within a relatively short period after the Big Bang. That is already extraordinary. It means astronomers may need to rethink how efficiently stars formed, how quickly galaxies accumulated material, and how rapidly early black holes could grow. Future observations will be crucial. As Webb studies more distant galaxies and collects better spectra, researchers can determine whether the unusual early objects represent isolated cases or part of a much larger population. If the pattern continues, existing models will need increasingly sophisticated explanations. And that is where the real excitement begins. Every distant galaxy is a record of the ancient universe. Every spectrum provides another clue. Every unexpected object gives scientists an opportunity to test their assumptions. The greatest discovery may therefore not be that Webb has destroyed our understanding of cosmic history. It may be that Webb has shown us how much of that history remains unexplored. The early universe was not necessarily impossible. It was simply more complicated than we once imagined. And with every observation, Webb is helping humanity move closer to understanding how darkness became stars, how stars became galaxies, and how the magnificent structure of the modern cosmos emerged from the earliest moments of time.